Alright, a little bit more detail here. So we're looking at the respiratory chain and how it creates a proton gradient. And this is very important. We're talking about the proton gradient here. And we should know that there are two steps in oxidative phosphorylation. First, the protons, the hydrogen ions, are pumped out of the mitochondrial matrix during the redox reactions in the respiratory chain. And secondly, the protons move back into the matrix space through a proton channel that is coupled to an ATP synthesizing enzyme. And we'll look at that in the next slide. So remember that a proton motive force drives this ATP synthesis. Now let's look at the membrane difference here, because we are looking at a difference between the membranes and this gradient that is created, and we can see that there's a 150 millivolt difference. This is a big difference between the membranes. So we have a voltage difference and we have a concentration difference, and both of these are driving these hydrogen ions out and in. So recognize that we have an electrical difference and we have a concentration difference, and that these will make a difference and will make them want to cross over the membrane and then force the ions back. This is what drives this proton gradient, and this is why we can generate ATP, because of this difference. This system is very similar to how nerve cells have a gradient difference. In nerve cells, for example, nerve cell difference is a negative 90 millivolts. In this case, it's 150 millivolts. Okay, so let's remember these important parts as we move on to talk more in detail about the electron transport chain.